This is a video on the Q5, the fifth question, FRQ. Somebody developed these questions. They seem discombobulated a little bit compared to other FRQs, but it's a good start. I'll be building new ones that I feel are most adequate for your assessment, but this one suits the fancy. The first part A says let the function be derivatives, blah 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 blah. It says here is the series that's given. Then they ask you to find the value of each one of the nth derivatives. So I thought about it. If this is a Taylor series polynomial, which it says it is, centered at -2, that means that I would find the derivatives in the coefficients. Remember, when we make Taylor series polynomials, you find the derivative at the center, which here is -2. And then once you find the derivative values at the center, you divide by the n factorial to create the coefficients. Step 1, derivatives. Step 2 is coefficients. Then you write the polynomial. So I'm going to write out this polynomial. Usually that's always your best strategy, is to write it out anyway. So let's write this bad boy out. So I'm going to plug in 0. If I plug in 0, I get 1 times x plus 2 to the 0 power. Plus, now let's plug in 1. If I plug in 1, I get 3x plus 2 to the 1. Plus, plug in 2, I get 5 in the front part. Then I get x plus 2 to the second. And it says go to 3. It actually is it terminates. It's a third order Taylor series polynomial. That's what the question said. So plus, plug in the 3, I get 7 x plus 2 to the third. Now, where we're going to find these derivatives is we're going to find the derivatives in what I have to remember. Step 1 to writing these polynomials is you first find the nth derivative at the center, which they tell me is -2. Okay? And then what you do, second step, to find the coefficient is you divide by the n factorial. This is the coefficients of the polynomial. Your third step would be write the polynomial. That means that this coefficient and this coefficient, that one and that one, all stem from the coefficient step. Derivative divided by that, divided by the factorial. So this is the 0 term. So it means I have no derivative at -2, and the coefficient was 1. So that one was pretty straightforward. There's nothing there. It's just a constant term. It's nothing exciting. Now this one, that's 3. That's the first order. So the first derivative at -2 over first order 1 factorial has to be equal to that coefficient, because that's how you build the polynomial, 3. So we need the derivative at -2. So the derivative at 2 would be 3 times 1 factorial, because I'm just going to multiply both sides by 1 factorial. So that means I've got a 1 for the first one, I got a 3 for the second one. That's the coefficient. Now the coefficient comes from the derivative at -2 divided by the factorial. That's the second order. So second derivative at -2 over 2 factorial has to be that 5. That's how you get it. That's how you get the coefficients, is through this. So again, multiply both sides by 2 factorial, and I get the second derivative at -2 is 5 times 2 factorial, which is 10. And the last one, same process. This is the third order at -2 divided by 3 factorial has to equal that coefficient, which is 7. So my third derivative at -2 has to be 7 times 3 factorial, or 3 times 2 times the 7 is, I believe I could fly, and I just had a brain fart, 42. So now I have all my components in order to answer the question. The question says find all the derivative added together. So I've got the 1, the 3, the 10, and the 42. By the way, if you're really worried about your math, just circle this as your answer. By the way, the arithmetic should not affect your results. Now, if you went ahead and added it up, you do get 56. They'll accept both. You don't have to worry about them not giving you credit for that. This is a significant step. So they're going to give you points for just writing out the polynomial. All right, so even if you could just do that, do that. Okay? Any points you can get are points, and there's not many points on this assessment. So, next question, part B. Part B says, hey, this bad boy converges. Not only does it converge, they're going to ask you to find the value, but they're going to caveat with if it exists. The only way you could find a value for this thing if this is geometric. So I'm not sure if it's geometric, so I'm going to go ahead and I'm going to plug in my values. So I'm going to plug in 0. I get 2 to the 1 over 3 to the 0, subtract 1, negative 1. Plus, plug in 1, that's 2 square, over plug in 1, I get 3 to the 1, plus 2 to the third over 3 to the third, plus, and I'm hoping that's significant enough for me to see a pattern. Again, the only way I can find the value of a infinite series is if it is geometric. And again, how do I do that? I take the first term, a, over 1 minus r. So I'm hoping this is geometric. There's a couple ways to view this. I see right at the bat that the top is constantly multiplying by 2, and the bottom is kind of tricky, but it goes, see, this is clearly, if you do the next term, you'll see it even better, but it's 3 to the 1, and it's 3 to the third. So that's going up by 3 square. That tells me my r is 2 over 3 square, or 2/9. Now, if you didn't like that, you're not sure how to find it, you see if it's geometric. If it's geometric, then each previous term, like a ratio test, if I take this and divide by the previous term, so 2 square, 3 to the 1, I want to divide by the previous term, so instead of dividing, I'm going to multiply by the reciprocal, which is 3 to the negative 1 over 2 to the 1. If you compute this, you get 2/9. But it has to work for every single term. So I'm going to take this term, 2 to the third divided by 3 to the third, times, or divide by this one, which is to multiply by the reciprocal, which is this, which you can see gives me 2/9. Clearly I've established I have the r. It means it's geometric because it has that constant ratio of 2/9. So I've got r, my a is my first term. My first term is right here. Well, that's 3 to the negative 1, which is just, you flip it up, which is 3. So this is 2 times 3, which is 6. That means the value does exist. It's the first term divided by 1 minus 2 to the 9th. Again, why would I do any arithmetic? That's going to give just as many points if you compute the actual answer. If you do go ahead and finish this off, you get 54 over 7. Now, if you're taking the risk that you make a mistake, so just leave it like this. My suggestion, just one more 30 seconds of your life you don't need to waste. Next question. C. C say, do both of these things converge? Okay, let's take a look at what we got here. We got 2 different series. I like this because it makes me practice my series work. And these 2 are quick, and we should be able to identify them quickly. I'm not really sure, but if I look at this guy, if I'm not mistaken, the first term is k over 5. The next term is k over 5 squared. The next term is k over 5 to the third. That's geometric. All right, where my r is k over 5. And we know that if it's geometric, its interval of convergence has to be between negative 1 and 1. No exceptions. We don't have to worry about the ends here. So that means negative 1 or this k over 5 has to be between the two, which means k has to be between negative 5 and 5. So I have this established. And the next one over here, I'm looking at this and I'm looking at a 1 over n to the p. That's what my eyeballs are seeing. I'm thinking that's p series. Now to remind you, p series, if the p is greater than 1, it will converge. If p is less than or equal to 1, it will diverge. Now, okay, which tells me that this power, that power has to converge, which means it has to be greater than 1. Now this is where, I mean, you want to write this out, so if you make the mistake here, I think the first time I looked at it, I made this mistake and didn't pay attention. It does have absolute values. That's tricky. I know that the absolute value has to be greater than 1. That means whatever's inside of this has to be greater than 1, but it also could be negative 1 or negative 2 or negative 3. Everything inside of here has to be bigger than 1, which means 2k minus 1 could be less than negative 1. Again, repeat. Inside this has to be bigger than 1 when you take its absolute value, which means it could be negative, anything less than negative 1, because if I pick any number like negative 3, its absolute value would be greater than 1. So this is an OR statement. Again, if you wrote this, you're in good shape. You bought yourself a lot of points, because this is pretty much a 3 or 4 point question. So if you see this, then you get this. You might have points by just writing this, even if you get this part wrong. But add the 1 to both sides means 2k has to be less than 0, so k is less than 0. So there's another parameter. Or it has to be add 1, k has to be greater than 1. So it has to be in these 3 parameters. Now, I'm going to read the question again, which you always should do before you write a final solution and circle your answer. But it said, the question says, find the value of k, and it says k has to be an integer. So what I'm going to do is I'm going to look at the integer values. I need numbers less than 0 that fit in here. Those are all less than 0, and they're all fit in this parameter. And it needs to be greater than 1. So that means 2, 3, 4. I can't include any of them. I can't include the 5. So there's my solution. All right, D. Just because this last part does not apply, it's the hardest. Many times, don't worry about the part A or B or C. They may not even be connected. So just pay attention to the part you're on. And even if you need something from our previous section, ignore it. Assume you have it, or at least write something down, because points that are achieved don't necessarily have to be completing an answer. So even if you know that it's a ratio test, then write the ratio test stuff down. All right, this one says here, determine if the series blah, this guy, is alternating. Okay, right away, when alternating series, let me remind you what alternating has. Alternating series, you need 1, it needs to be alternating. It needs to be changing positive and negative. So I have to check that box. Second thing I need to do is I need to have it, it has to be decreasing. Which basically, and I'll explain in a minute, it has to be decreasing. And I'll explain it in a part, I need some space here because I'm going to explain that part too, because what the wording here makes sense after you think about it. And then the last part is you must check the limit as n approaches infinity of the a sub n. It has to equal 0. Those 3 parts make it alternating series. Generally, in principle, if you see it alternating and it's decreasing, it will be an alternating series. However, you also need to have this part checked. Now, if I read the whole question, it says, show how the ratio test can be applied to the series to give its conclusion. Okay, well, let's walk through my stuff. Let's write it out first. I don't even know what the heck this is. So let's write this out. I don't know. I'm going to plug in 1. So I got e over pi over 2. And then I plug in 1 here. That gives me cosine pi times 0 factorial plus e to the pi over 2. Now I'm plugging in 2. Gives me cosine 2 pi times 1 factorial plus e pi over 2 cosine 3 pi times 2 factorial. And maybe one more for good luck. Plus e to the pi over 2 cosine 4 pi times 3 factorial plus dot dot dot. I don't know. I'm not going to write them all out. I think that's sufficient for me to see pattern. I don't know how this is alternating. It's got to be this cosine part. So if I look at the cosine of pi, or cosine of pi is, let's see, I believe that is -1. Cosine of 2 pi, that's 1. Now I can see why it's alternating. Cosine of 3 pi, -1. Cosine of 4 pi is 1. So let's go ahead and put this together. I think I'm going to leave the factorials in there. So e pi over 2. By the way, writing this stuff out allows me to have a lot more vision than not writing it out. 1 factorial plus e pi over 2, subtract, and that one should have been negative, I apologize, over 2 factorial plus e pi over 2, 3 factorial. Okay, so it is alternating. Check! We've shown that. We've shown it's alternating. We've shown it. Decreasing. Well, now here's the part. It says something about use this ratio test. If it's decreasing, that means it's getting smaller. Well, we have the same thing at the top, and each time the thing at the bottom is getting larger, so it's decreasing. An easy way to verify or prove that it is a ratio. Take the previous term. So what we're going to do is we're going to take the limit as n approaches infinity of the a sub n plus 1 term divided by the a sub n term. If I do that, it's going to allow me to show that in fact it is alternating, or I'm sorry, that it's decreasing. So we're going to use the ratio test to do this. I wouldn't have to do that just to show it's decreasing. I can show I can write this out and show that, say, yes, it's decreasing. But here they're saying use the ratio test to show it. So this is an extra little flavor. They're saying, hey, use the ratio test. So I'm going to stick this stupid thing in a ratio test and see what I get. What would be really neat is if I get a 0. Okay? Anywho, let's go ahead and do this. So limit n approaches infinity of the a sub n plus 1 term is e pi over 2 plus cosine pi n plus 1 times, or still on the bottom, then n plus 1 minus 1 is this n factorial. Divide by the a sub n term, which is this term, only I flip it over. So I'm flipping it over and I'm writing it down. Now I'm going to chill out because ratio test, I just got to line stuff up. I'm not even thinking. I'm just going to put the e pi over 2 over e pi over 2. Yeah, I can cancel that. Times. Now let's put the cosine parts. Now this part's kind of a farce, but I'm going to go ahead and write it anyway. I'll explain that in a second. So I wrote that part. Times, now I've got n minus 1 factorial over n factorial. And as I said, clearly this cancels. This here, all I'm doing is saying there's one extra. So no matter what n is, you're going to get a 1 over negative 1, or 1 over 1, over negative 1 over 1. It doesn't matter. It's going to simply, this is your alternating part. So that means all I really am going to do is take the limit of this piece. Yeah, but I need to reduce it, don't I? I never reduced it. Of course, there's an n here, and this one doesn't have the n, so this is 1 over n. I've reduced it, so let's get rid of this piece. So I've got this. N approaches infinity of 1 over n is equal to 0. So it really doesn't even matter what this comes out to be. So my limit comes out to be 0. That tells me that it definitely decreases, and I now have shown that the a sub nth term is also 0. So have I shown its alternate series? Did I use the ratio to do so? Yes, I did. Okay, that concludes that one. I'm sure we'll be doing more videos together.